Is my screen is visible to you?
Yes.
Okay. 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 Let's study. So in the previous class, we were discussing this one, that why has light a double nature, and this is not so much important. So don't think this is our first class, and this the first class will be the from the related to the topic that we have for. Okay, so let's start. So first of all, I'm talking about the refraction of light. We have the two topics. One is the reflection, reflection, and another one is the reflection. Okay, so we have that we were discussing about this topic, that when a light ray, when we say that what is reflections, when a light ray falls on a shiny surface, means we have a ray of light and it's fall. Okay, okay. So when we have a shiny surface, let me explain what is reflections. Reflections we will study two things. One is the reflection, another one is the refraction. Reflection and refraction, these are the two phenomena that is done by the light. Refraction. Okay, so what is the conditions that when a light travel, okay, when light is travel and strike on a shiny surface or a regular surface or irregular surface, and it bounce back to its original medium, means if this is the first medium, this is air, the light should come back to air. Light should come back to air. This phenomena is known as reflection. This is known as reflection. Reflection. When a light it strike on a surface, on a shiny surface, that's this is a mirror. Okay, and it comes back to its original medium. Medium is not changing. The condition should be that medium is not changing. Air, the light strikes in the air, strike the shiny surface and go back to the air. So this is called the reflection. Okay, what is refraction? The bending of light rays when it passes from one medium to another medium. For example, this is water. Here is water. Okay, here is water, and the light ray is passing. The light ray is passing from air. That the light ray, it is incident at some angle, and it bends, and then it goes back. Okay, so this bending of light is called refraction. When it passes from one medium to another medium, we called it that this bending of light when it passes from one medium to another medium is called refraction. This is called normal, this is normal, this is normal. Okay, so this is the incident angle, this is the refracted angle, whatever we will discuss it later. Okay, so what is the condition that for the refraction we must have the two medium. One first is there must be two mediums. One is the one may be air, other may be water, one may be water, other may be glass. So light must travel from first medium to another. Yeah, one medium to another. From one medium to another medium. Okay, light must travel from one medium to another medium. Okay, this is our first condition for the refraction. And the second one is it must bend. It must bend from away from the normal or towards the normal. It must bend. It is sufficient. Matlab light must bend its path. Okay, light must bend from its path. Okay, from its path means if the light could have traveled, means if the light is continuously traveling in this medium, so it could have passed to this, but actually it bends from here to here. So we will say that this bending phenomena, if the light, if I suppose if I pass the light normally to this water, or normally with this with the boundary of water, the boundary of water is this one, and if I pass the light normally, then it will goes undeflectedly or unbending, means it will not bend, it will goes without bending and will pass the medium. So here is, we will say that no refraction is taking place. No refraction is taking place. So dear student, you need to keep in mind that first condition, that light must travel from one medium to another medium. Otherwise, the light will not bend. And the second thing is that it must bend it's from its path. If any one of them is not happening, so we will not say that it is a refraction. So we will be going to study these two phenomena thoroughly in a very easy and a convenient manner, that what is reflection and what are the applications of reflections, what happens when the reflections take place, and what are the applications of reflections. Similarly, we will be going to study the refractions. Why does the refractions occurs? What are the consequences of refractions, applications of refraction, that we will be going to study in this chapter. Okay, so let's move. So the bouncing back of light in the same medium, this is must, first condition, and in the same plane, the plane must be same. When it is strike on this plane surface is called refraction. We called it when the light ray strike on a medium and then it bounce back in the same medium in the same plane, then we said that it is a reflection is taking place. Okay, and we have the two laws. I mean, we have the laws of reflection. One is that the the angle of incidence and the angle of reflection must be same. And it is an experimental measure that when we strike a ray on a medium, okay, on a surface, on a shiny surface, then the angle at which it incidence is the same at which it reflected or bounced back. For example, if I you need to keep in mind that we need to, whenever we are just measuring the angle, we measure it from the normal. This is if this is one question. I will ask you one question. Okay, first of all, if I'm saying that this is a light ray, this is a light incident ray, and this is an incident ray, and it is like this shiny surface. Okay, and let's suppose this angle is 30 degree. Let's suppose this angle of incidence is 30 degree. So the light will strike on this surface and will move in such a way, at such angle, that with the normal it will make 30 degree with this one. Okay, so angle of incidence is always measured with the normal, not with the plane. This angle will be 60 degree. So if it is being given to you, a 1 marks question arises from this one, that you have a shiny surface, okay, and it is being given to you that this is a normal. Okay, this is a normal, and it is being asked in the question, in the examinations, that if this is the angle, this is 30 degree angle, then what is the angle of refraction? Option A is 30 degree. Option A is 30 degree. B is 60 degree. Option A is 30 degree. B is 60 degree. C is 90 degree, and D is 0. What would be your correct answer?
Option
A.
Option
Option A. No. If I'm saying that this is the angle of 30 degree, then the angle, what is being asked? Calculate or tell or find angle of refraction, reflection. So Tanishka, do you think is Biju is correct? A option is correct.
I think it will be B.
Yeah, it will be B, because I've told you that when we are going to measure the angle, we will be measuring the angle from the normal. So if this is whole as 90 degree, if this is whole as a whole 90 degree, then this angle will be considered as 60 degree. Okay, this angle of incidence is always calculated from the normal. So angle of incidence is 60 degree. So the angle of refraction will be 60 degree. So here the angle of incidence is not given. 30 degree is not the angle of incidence. It is actually the angle between the incident ray and the plane surface, the striking surface. So that is 30 degree. This is 30 degree. This would be 30 degree, but this is not the angle of refraction. No, this is not the angle of refraction. The angle of refraction is 60 degree. Got it?
Yes.
Or still having some doubt? No? Okay, so please let me discuss the second, and then you need to take the screen. First, please take the screenshot of this one, and we will be going to discuss. Taken?
Yeah.
Okay. So let's move further. Let's move further, dear student. So the second angle, the second statement is the law of refraction is that the incident ray, the reflected ray, and the normal light on the same plane. What does this statement means? The same plane. When we are talking about the plane, what does this statement means? The normal. What is normal? Normal is this one. This one is normal. Okay. So this one normal. The incident ray and the reflected ray should lie in the same plane. So let me explain you what does this statement says that if we have this 3D object, okay, if we have this 3D object, and if I said that if I have a laser light, if I have a laser light of red color, okay, first of all I need to explain that here one thing, that let me explain you. Wait a minute. Oh, what is this? Oh, wait a minute. Yes, my slide exists. Wait a minute. Okay, dear student, I was explaining you this one. That is my screen is visible to you?
Yes, it is.
Yes. So if I'm saying that this is a plane, okay, this is a plane. Let me make here another one so that I can explain you one more time. I'm making a cube here, cuboid, sorry, cube. Okay, and this is a cube. Okay. So if I'm considering this as a positive x-axis, this will be considered as negative x-axis. If this one is positive y-axis, this will be considered as negative y-axis. And this one z is, if I'm coming here, taking here, so this is considered as positive z-axis, then inside the screen it will be considered as negative z-axis. You understand that? Okay, do you understand that, dear student?
Yes.
Biju, do you understand? So if I'm saying that this is a positive x-axis, so this will be a negative x-axis. If this I'm taking as a upward distance, upward as a y-axis, so this will be downward, will be considered as negative y-axis. Into the screen is negative z-axis, so outside the screen will be positive z-axis. Okay, so if I ask you that what is the plane of its first face, means this face, the face that is appearing on the screen. So I'm asking that what is the plane? So the plane will be this one and this one. So here is the x and y. Means this face, this first face is, I mean this first face is going to have the geometry that is x and y plane, x and y plane. Okay. In the similar way, this plane, this side plane. Tell me, Biju, which plane of geometry it is going to have?
X and
Y and Z, because it is made up of Y upward and into the screen, that is into the screen. Okay, Y and Z, so it is going to have Y and Z geometry. Okay, Y and Z geometry. In the similar way, this one and this backward face is going to have this is X, means horizontal is X and upward is Y, so it is X and Y. Okay, similarly this face is going to have the similar of this one, similarly. Okay, and a top face, top and bottom is made up of X and Z, top and bottom is made up of X and Z. So if I'm saying that if I put a laser light here, red color laser light, and if I strike it in the plane such that this is parallel, the light is moving parallel to the face, that this face parallel to this face. Okay, so if I turn on my laser light and I suppose this is a I'm considering this as a mirror, this side as a mirror, or minus z axis as a mirror. So when the light is striking, so it will goes in this direction, it will goes in this direction, in this direction, in this direction. So this incident ray is in which plane? It is in z minus z, or we can say z and y plane. The incident red color light is in the plane of Z and Y plane. Z and Y plane. And the refracted ray is also in the Z and Y plane because it is touching to this one. And the normal, if I'm making the normal, it is also in Z and Y plane. It will not be like this. It will not be like this. If I'm having the incident ray like this, it cannot be reflected in this way, in this way, or I cannot have the normal in this plane. That is this one. I cannot have the normal in this plane. That is the Z and X plane. If the incident ray is in incident ray is in YZ plane, the reflected ray and the normal, if I'm saying normal, the normal cannot be in this plane. That is the plane of this bottom is the plane of this bottom is Z and X, is Z and X, Z and X. So it cannot be in Z and X. It will be, and it must be in, it cannot be like this, making the 90 degree with this plane. No, it cannot be like this. It must be in this plane. It must be in this plane. And the reflected ray must be also in this plane. And the reflected ray must also be in this plane. In a similar way, if I put the laser light at this point and I strike this as a mirror, and considering this as a mirror, if I'm considering this as a mirror, then this incident ray, the reflected ray must be in the same plane, and the normal will be also in this plane, and the normal will be also in this plane. The normal cannot be like this. No, I will consider the normal like this. No, you cannot consider normal like this. From this point to this face, you cannot make the normal. The normal should be in this, on this face. That is the Z and X plane. Z and X plane. Got it? Got it, dear student?
Yes.
So this is the way that we have the second law of refraction, that the incident ray, the reflected ray, and the normal lies on the same plane. They cannot change their plane. So this is the law of reflections. Another one is the regular and irregular reflections. Regular reflection is one in which all the incident rays are parallel. If the incident rays are parallel, then the reflected rays will be parallel. And the irregular reflection is one. Irregular reflection is one when the incident rays are parallel, but the reflected rays are not parallel, because the surface is not regular. Okay, surface is not regular. Why the surface is not regular? Why it is showing? It can be simply understood by this one. Tanishka, can you tell me why this is not regular? I have taught you this one. Tanishka, I'm asking you, beta. Tanishka, are you there in the class? Okay, let me explain you. So regular reflection is the one in which the surface should be shiny and smooth. It does not have irregular sides. And the irregular surface is one in which the surface is not shiny. And why this? If I strike the
So
incident
you were
rays,
calling me? Sorry.
yeah, I was calling you, but you were not responding. Where were you,
Sorry.
beta?
Actually, I'm having network issues.
Okay.
My Wi-Fi is not working.
Are you using the laptop or mobile phone for this for the connection?
I'm using the mobile only.
Okay, you are using the mobile phone. Okay, no problem. But it will be more better if you use the laptop and use the internet connection by using the wire, not through Wi-Fi.
Okay.
Okay, beta, just listen to me. This is very. So I was asking that why here if I strike the parallel incident rays on a surface, that is irregular, then the reflected rays are not regular. That you see that here are the parallel, and here the reflected rays are not parallel. This goes to this side, this goes to this side, this one goes to this side, this one goes to upside, this one goes to that side. So why it is showing? Why it is behaving like this?
Because the surface is irregular. It's not shiny and smooth, and
Yeah.
it's having bend.
Yeah, for example, why? Because it is following the law of reflection. For example, if the surface is like this, when the point at which the incident ray strikes, the normal will be like this. So for example, this incident angle is 30 degree for this point surface, and this will be 30 degree for this surface. Okay, 30 degree for this. Okay, but if I find that this is another ray, this is same another ray, okay, that is striking, but at this point the surface is not like this. Instead of that point, it is behaving like this. It is behaving like this. So when I make the normal, this will be like this, and this, let's suppose this is a 10 degree, this is 10 degree, so this will be 10 degree. So the same, this is a parallel, this one, these two rays are parallel, this one and this one are parallel, but their reflected rays are different. The reflected, its reflected ray is like this, and this reflected ray is like this. Why? Because at the point where this ray is incident, the surface is behaving like this, and the point where this ray incident, the surface is behaving like this. So because of this angle, they have the different angle of incidence, and when they are going to have the different angle of incidence, the reflected ray must be irregular. So in the regular and irregular reflection, both the law of reflection is called law of reflection is followed. Got it, dear student?
Yes, sir.
Or still having some doubt? Let's move. Take the screenshot of this one, please. Copied. Copied, dear student.
Yes, sir.
Let's move to the
Yes.
next. Let's move to the next. Okay, here we have written that in both regular and irregular reflection, both the laws is followed. Okay, now we are talking to the next is the reflection through plane mirror. Now this is our topic, the reflection through plane mirror. Okay, this is in our syllabus and we need to talk it about. So what is plane mirror? Plane mirror is that mirror that is going to have infinite focal length. Actually, you have not studied about the spherical mirror till yet, so I'm not talking about the focal length. But 1 marks question, since we are talking about the plane mirror, so we said that here the point come, the star I'm making here as point, that the focal length of plane mirror is infinite. Okay, got it? Moreover, the image form is of same size as the object. What is this? What I'm saying, that whenever we are making a plane mirror, we are seeing we are looking into the plane mirror, and an object is going to have image, or an object is forming its image in the plane mirror. The condition or the image form in the plane mirror is of same size as the object is. Means the image is not small, the image is not, we can say that it's not diminished, it's not enlarged, it is of same size as the object is. So the image form is of same size as the object is. Okay, as the object is. Another one is the image form is at the same distance. Means if I'm saying that this is a plane mirror, okay, and if I'm keeping up an object here, let's suppose this is of 2 centimeter object. Okay, this is of 2 centimeter, so its image form will be of 2 centimeter height. Okay, and it is of 2 centimeter height. Okay, 2 centimeter height. And if I'm saying this is at the 5 centimeter, this is at the 5 centimeter, then the image will also, the image distance from the mirror will also be 5 centimeter. Okay. Okay. The image form is at the same distance as the object from the plane mirror. The second one and third one is they form the laterally inverted image. What do you mean by the word laterally inverted image? Not only the plane mirror is going to make the laterally inverted image, all the mirrors, if it is forming the virtual image, that will be considered as laterally inverted image. What do you mean by the laterally inverted image? Laterally inverted image means the left become right and right become left. What do you, that if you see B like this, so the image of the B will be like this, means it will be laterally inverted. And there is an application that not only the plane mirror is going to make the lateral inverted image, dear students, every mirror is going to make the laterally inverted image. Okay, that's why we don't have the plane mirror in the cars. We don't have the plane mirrors. Side mirror of the cars is of convex mirror. They are the side mirror and these are the convex mirror. And these convex mirror is designed to see wider view, means they can see the wider view of the objects or the vehicle that is coming behind. And you have seen that the ambulance, on the ambulance, it is being written here that ambulance means we find that ambulance. So the ambulance is being written like this one. On the ambulance, it is being written that in front AMBLUANCE. So when you find that this is the ambulance, when you see this one in the mirror, then this will become the lateral inverted, left become right and right become left. So this will be written as like ambulance. Okay, when we see this one ambulance, so when we find this one in the mirror, then it will we can say that the driver will be able to see that in the correct manner, and he will find out that ambulance in the correct manner. So because of this lateral inversion, the ambulance has become laterally inverted already, because when we write something laterally inverted, then the image form in the mirror will be automatically in the right positions. Okay, if I write B like this, like already laterally inverted in the mirror, if I have B like this, then when I find its image, it will be like this. Okay, so that will be correct. So got it what I want to say? Got my point?
Yes, sir.
Okay, so please copy this one, or copy or take the screenshot, whatever you like. But your notes should be completed, and you must have the complete notes. Okay. Do you want to have science stream in the next 11th standard, or you want to shift to the different stream?
I didn't decide.
You will be going to have the different stream.
No, I didn't decide it yet.
But you must decide, because we need to teach you to that level, because in the 10th standard syllabus, we need to teach something advanced that will help you to understand the 11th concept and 12th concept. Otherwise, otherwise normal NCERT and some correct explanations is enough if you are going to take the commerce or humanities. Okay, so decide it, and then we will help you. So have you taken the screenshot with Tanishka and you both?
No, sir, 1 minute.
Okay.
Yes.
So if a question arises here, that an object is placed at a distance of 5 centimeter from the, listen to my words, an object is placed 5 centimeter from the plane mirror, what is the distance between the object and its image?
$10 centimeters.
Yes, it would be 10 centimeter. Object, the distance between the object and the image will be double, means 5 is object is placed at a 5, and the image is also, it will be formed at 5 from the mirror, and the distance between the object and the mirror will be 10 centimeter. Got it? So let's move further. Dear student. Copied, Biju?
Yes, sir.
Okay, let's move further. So next is that the image form is virtual and erect. The next point and the fourth point is the image form is virtual and erect. What do you mean by the word virtual? Virtual means not real. Opposite of virtual means that do not have any real existence. So if I'm saying that an object is forming a virtual image, means that image is not real. For example, if I have an object that is placed at a distance of 5 centimeters in front of a plane mirror, and I'm saying that its image will be formed behind the mirror, and that will be at the distance of 5 centimeters from the mirror. Okay, this is 5 centimeters, this is 5 centimeters. But I am having a mirror of thickness of 5 mm only. And why I'm saying that the object is going to form the image of 5 centimeter or 5 meter? Why? The thickness of the mirror is 5. And I'm seeing that the object is placed behind the mirror. So actually the image is not real. Okay, image is not real, that is forming behind the mirror, but actually behind the mirror is nothing. When I check, behind the mirror is nothing. So that's why we considered it as virtual image. Erect, the word erect means upright. The word erect means upright. Okay, dear student, the word erect means upright. Okay, so you need to keep in mind here is that, dear student, that whenever the reflected rays, the original reflected rays meet together, the image formed is real. Whenever the original reflected rays meet together, the image formed is real. And when we assume that the rays are considered to meet there, that the image is considered as virtual. For example, let me explain you this one. Let me explain you. This is a plane mirror. Okay. Let me explain you. This is a plane mirror, dear student. Okay. And we have an object. We have an object here. Okay. And let's suppose the first ray is moving like this. Okay. That the first ray is moving like this. And this is at the 90 degree with this one. So if the angle of incidence is with the normal is 0, then this reflected ray will be like this. This reflected ray will comes on its original path. Okay. But another ray that I'm passing through this one, we need two rays. One is this one, and another one is that I'm striking this ray and this one to this one. Let's suppose this is striking, this is the ray that is striking this object at this point and striking the mirror at an angle of 30 degree with this one. So this will rebound back and will make an angle of 30 degree and will goes to this one, this side. Okay, so this is another 30 degree. So we find here, dear student, that the angle of incidence and angle of refraction is 30 degree here. The law of reflection is being followed. Here, the angle of reflection and with the normal is 0. So the ray will be rebounded back to its original path. So we have the two reflected rays. Which one? This one. This one is the incident ray and this one is the reflected ray. So this one is the reflected ray. Okay. And another reflected ray is, this one is incident and this is one is rebounding back on its original path, and this one is another reflected ray. Do you think that these two rays will meet together ever? If I keep on increasing this one, do you think that these rays would meet together? Do you think?
No, sir.
No, they will not, because their distance is being continuously increasing. Okay, so we will consider that these rays are not meeting. Is not there. But if I see that if I increase these rays in the backward directions, I'm assuming that these rays are meeting somewhere in the backward. So if I increase this, continuously increasing here, okay, and this one I'm increasing. So they meet here, and there they will be forming the image. There they will be forming the image, and that will be of same distance and same height. So we see here that these rays are not actual reflected rays. So when the not actual reflected rays are not making the image, that type of image is called virtual image. And in case of mirror, they will be always formed behind the mirror. In case of mirror, they will be always formed behind the mirror. But in case if the rays meet, the original reflected rays meet, for example, I'm going to explain you. Let's suppose this is a concave mirror. This is a converging mirror. We are not going to this topic, but let me explain you. So for example, this is an object and this is its focal length. Okay, this is an object. A ray passes from this one and passes to the focus. Another ray goes from the focus and comes parallel. So when a ray passes through the focus, it comes parallel, and when a ray passes through the focus parallel to this one in principal axis, then it comes to the focus. We have not studied this one, let it be, but I'm going to explain you here that this is the incident ray and this one is the reflected ray. This one is another incident ray and this one is the reflected ray. They are originally meeting. The original reflected rays are meeting. So this type of image form is real. This type of image form is real image. So whenever the original reflected rays are meeting together, we consider it as real. And whenever the original reflected rays are not meeting together, we consider it as a virtual image. Got it? Do you have any doubt, dear student?
No, sir.
No. Next one is, we have a formula of magnification. What do you mean by the word magnification? Magnification. Magnification, the word magnification means something is being magnified. Okay. For example, if I'm saying that I have an object of 2 centimeter length, and its image is the image formed by this by the mirror, by any mirror. I'm not talking about the plane mirror or anything. The image formed is of 4 centimeter. So how many times this image is magnified?
2 times.
2 times, twice. Its original, it become twice or twice its original.
Yeah.
Okay, 4 centimeter. This is so here we say that the magnification is, or we can say that the magnification is 2. We say that the magnification is 2. So whenever we are going to have the virtual image, whether in the lens, whether in the mirror, whether it will be concave mirror, concave lens, convex lens, plane mirror. If I'm saying that the image is virtual, it means it is going to have plus magnification. The plus, any positive magnification. Magnification is positive for virtual image. Okay. So actually, what is magnification? Magnification is height of image upon height of object. Okay, height is the ratio of height of image upon height of object. So if the image is 2, if the image formed is 4 centimeter and the actual object height is 2, so we can cut it and we can say that the magnification is 2. So if the magnification is 2, it simply means that this is a magnified image, 2 times magnified, the original. Okay, if the magnification is 1, when would be the magnification 1? When the image and object is going to have the same size. For example, if the object is 5 centimeter and the height of the image is also 5 centimeter, then magnification will be 1. So tell me, what would be the magnification formed by the plane mirror? What would be the magnification formed by the plane mirror?
1. 1.
1. Positive 1 or negative 1?
Positive.
Tanishka, is Biju is correct? Tanishka?
His voice was not clear.
But I'm asking here that I'm asking the magnification, what would be the magnification of plane mirror? What is the magnification of plane mirror, beta?
Yes, 1.
Plus 1. Here the plus sign is indicating that the virtual image, because it is from virtual image, and 1 is indicating that the height of the image is same at the height as the height of the object. The same size of image as that of an object. So dear student, we have an NCERT question that what do you mean by the statement that the plane mirror has magnification positive 1? So you have to write that the positive indicate the virtual, image is formed, and 1 is indicating that the image size means there is no magnification. The image size is the same as that of object. and the distance is also. We have another formula for the magnification is the V by U that we will be going to discuss later. Okay. And the distance of the object we considered from the mirror we consider as U, and that of image we considered as V. Okay, dear student, do you have any doubt?
No, sir.
So here we find that height of the object and height of the image is same in case of plane mirror, and that one more thing, that the distance from the mirror U of the object from the mirror and the image is also same. So here is that why is the image we have a question, why the image of the plane mirror can't be obtained on a screen? Why we say that the image? So because image the screen in actual plane mirror, when we have the plane mirror, so the rays are not actually transmitting, the light is not moving into the light is not actually moving into the mirror, but it assumes that it is meeting there. We are assuming that these are the, if we keep on increasing this one, here the reflected rays are meeting, okay, in the backward. So dear student, you need to keep in mind that when we are obtaining a screen, when we are obtaining an image on a screen, only the real image can be obtained on a screen, because we put the screen in front of the mirror. We put the screen in front of the mirror, not behind the mirror, because actually the rays are not moving inside into the mirror. They are not passing. They're not penetrating into the mirror. So whenever we are having a mirror, when we are having a screen to make the image of the object, so during that time, dear student, you need to keep in mind here that the original reflected rays must meet, means these original reflected rays must meet. And here we find that because the actual reflected rays do not meet in front of the mirror, to form the real image, only the real image can be obtained on the screen. We can only obtain the real image on the screen. We cannot obtain the virtual image on the screen. So please note it down. Then we shall be moving to the next topic. When you copy it, please let me know, dear student. Done, Riju?
Yes, sir.
Okay, let's move further. So this is that was we were explaining here that virtual image in the now the number of maximum images that can be formed when two plane mirrors are inclined at some angle. This one is this one, and this one is another plane mirror, and these two plane mirrors are inclined at some angle. So that will be given by, the number can be divided by n is equals to 360 upon theta minus 1. This I am writing here just for the competitive exam. So many times it is being answered. Find the number of image found when an object is placed, when the two plane mirrors are inclined together and object is put between these two, and how many images can be formed. So if I'm saying that we have the plane mirror and they are inclined at an angle of 90 degree with each other, so theta upon 90 minus 1, that can be, you can divide it by 4. So that can be maximum 3 images can be formed of an object when an object is placed at an angle of 9, when the two mirrors are inclined at an angle of 30 degrees. So please, and if the mirrors are inclined at an angle of 30 degree, means if we have two mirrors and they are inclined at an angle of 30 degree, we put the object, then the number of images can be formed is 11. Okay, so please also copy this one. This is also an important statement. Tanishka, is my voice is audible to you clearly?
Yes, sir.
Okay. Done, beta?
Just a minute.
Okay. Have you done, Biju?
Yes, sir.
Anishka, should I move to forward or you are still writing?
Yeah, okay, done.
Okay, let's move further. One more thing you need to keep in mind about the interesting fact of plane mirror is that some important fact of plane mirror is that no matter how small a plane mirror is, it always forms the full image of an object. For example, if you have this much size of a plane mirror, okay, and you have an elephant, so a full image of this elephant can be formed in this plane mirror, but you need to see a different angle. For example, if this is an elephant, this is an elephant, okay, from here to here is the elephant. So if you are looking at tail, or if I'm saying that in front of this one is the elephant, this size is the size of the elephant. Okay, so to look his uh, tail, this one is tail portion and this one is its trunk. Okay, face, we can say, or head. So to look his face, you need to come here, and when the reflected rays will come to this one and it reaches to your eyes. And to look his tail, you have to go there and you have to, but the image form will be full image will be formed. No matter how small a plane mirror is formed, it always form a full complete image. No, it will not happen that no, the plane mirror is going to, because the size is small, it is only going to make this image of the trunk only, no tail. No, it will form. If they are the two person, they are looking into the mirror from the different angles simultaneously. One will see its tail, another will see the trunk. But the image will be formed fully formed, or we can say that you may not be able to see the whole elephant in a single at one time, but when you change your positions, then you will be able to see the whole image of the means you will see the different parts of the elephant. When you move down, then you will be able to see its back. When you move upward, then you will be able to see his feet. So depending, it is independent that how small is a mirror, it always forms a image of a full object. Okay, there's so many times a question comes that what happens if we wrap the half of the concave or plane mirror, the image will be formed, sorry, convex lens. If we wrap this one, okay, or if we wrap the half of the plane mirror, so if are having, will it form the full image or the half image? The image will be formed fully. Image is not going to be half. If we have a point size plane mirror, it will be going to form the full image. Okay, and you need to keep in mind, for a person to see his full image, see his full image in the mirror, in the plane mirror, the size of the plane mirror must be at least the half of the size of the object of the person. I'm talking about the person. So if you want to see the full image, if you want to see your full image in the mirror, the at least the size of the mirror must be half of the size of your height. Otherwise, if you have a mirror that is smaller in size than your half height, okay, then you will not be able to see your image, full image, completely at one time. The image formed is, we're not saying that the half image is forming, but you will not be able to see your full image at single time. You need to move different angles. If you want to see your feet, then you need to stand on the table or chair. And if you want to see your, means this should be done. Sometimes we did, if we have a small mirror, then we used to do, then we turn on the bed, we go on the bed, and then we see ourselves. Okay, so that's the simple, that at least we must have a plain mirror that must be half of your size to see your full image. Okay, got it?
Yes.
Please copy this one, and then we shall be moving towards the next topic. Done?
Yes.
Let's move further. So state four characteristics is a question that will be arising. That state four characteristics of the plane mirror form. So you can say that it form the same size, or the image form is same size. First one. Second one is the object, the image formed is at the same distance, laterally inverted, okay, virtual and erect, and you can say that plane mirror always form the full image of an object. So these are the characteristics of the plane mirror. Okay, four characteristics. Then next one is, an object is placed at a distance of 10 centimeters from the plane mirror. What would be the distance from the mirror? So I said that it will be 20. Okay, got it? Got it? That's very easy.
Yes.
Okay. So this is another topic that we'll be going to study in the next class. That is the image formed by the spherical mirrors, and that is very important from the examination point of view, and that we'll be going to discuss in great detail. So I think for today that's enough. Okay, because it will be late if I continue. Okay, because this is a different topic, and not a different topic actually. This is a new topic, the spherical mirror. So we should start it from the beginning so that we can have 1 hour to explain this one. Okay, so I hope you understood. Do you have any doubt regarding to this topic that we have studied? The laws of reflections, the incident ray, parallel and the normal ray lies on the same plane. The incidence angle must be equal to the reflected angle. Okay, so you need to keep in mind that the incident ray, the incident angle, the angle of reflection is always measured from the normal, not from the plane of the surface from which the rays is striking. Okay, it is always measured from the normal. Okay, got it? The condition for reflection is that the ray must go strike on the surface, shiny surface, and will come back to its original medium. Medium change should not be there. And the condition for refraction, the condition for refraction is that the object, the ray should travel from one medium to another medium, and secondly, it must bend. If the ray is still moving from medium 1 to 2, but it is not bending, we find that when the ray is normally passed to the surface or the medium, then it do not bend. It simply goes out without bending. So when such type of phenomena occurs, we say that there is no refraction is taking place. The condition for refraction is bending. In the definition, we have the bending of ray of light when it passes from one medium to another medium. So bending must be there, and then pass from one medium to another medium, there must be two things. Okay, and for the topic for the reflection, there must be two essential conditions. One is the ray should, the light should pass or should remain in the one in the medium, same medium, and secondly, the plane should not be changed. The plane of geometry should not be changed. The plane should remain same. Okay, so got it, or still having some doubt regarding to this magnification that we have studied thoroughly, everything that we have studied? Do you have any doubt regarding to this, Biju and Tanishka?
No, sir.
No, beta. So tomorrow we will be going to have discuss the maths. One day we will be going to have maths class, another day we will be going to have the science class. Okay, and whenever we are having any problem regarding to any topic and you are having exam, then we can change the schedule according to this, according to your need. There's no need to do this thing, but please be continue and do not miss the class, any class, if you want to complete your syllabus on time. Thank you so much for joining this class. I hope you understood. Okay, Biju.
Yes, sir.
Okay, do you understood? Do you have any doubt?
No, sir.
Okay, thank you so much for